Today we're going to cover section 10.3. We started it a little bit last week when we talked about combining like radicals and simplifying to combine like radicals. We're going to move ahead today with a little bit of review on those two and add in multiplying radical expressions. You may consider we talked about pausing this video now and going back to your notes worksheet and solving the first few problems before you move on to the next example. Plus 3x, since x and x is talking about the exact same thing, if you have 5 of those and then you add another 3 of those, it would give you a total of 8 of whatever it is that you're talking about. So 5x plus 3x is 8x. You know, same thing if you have negative 11xy minus 9xy. You are talking about the exact same terms. So negative 11 minus 9 would leave you with negative 20 xy's. Well, the same rules apply if you're talking about irrational numbers, such as if you have 5 radical 2's and then you add 3 radical 2's, essentially your radical 2 could be your x because x represents the same number. So if you had 5x plus 3x, you would have 8x. Well, if you have 5 radical 2's and 3 radical 2's, that leaves you with a total of 8 radical 2. Same thing if you would have negative 11 radical 7's minus 9 radical 7. Again, this is your like term here. So you'd have negative 11 minus 9, which is negative 20 radical 7. So you can think of it, like you've gotten very good at with your variables, but now we're just talking about irrational numbers that we want to leave in Now that you know that you can combine like radicals, you can manipulate or rewrite or simplify some of these, to rewrite them so that you can combine like radicals. So what I'm talking about, if you have something like 5 radical 3 minus the square root of 12, you can rewrite radical 12 as radical 4 times radical 3. Well, you can simplify radical 4, that's 2, so you have 2 radical 3. And what you started out with, you were subtracting. So now you have 5 radical 3 minus 2 radical 3, which when you combine those, you get 3 radical 3. Some of them might take a little bit more work, such as 5 radical 32 minus 4 radical 18. Well, really what you want to look for is those perfect squares within these. Let's see, the square root of 32 can be written as the square root of 16 times the square root of 2. And radical 18 can be written as the square root of 9 times the square root of 2. And maybe you can see where I'm going with this. I can take radical 16, and I know that the square root of 16 is 4. So really what I have is 5 times 4 times my radical 2, which is irrational. I can't really break that down any further. And then if I look at my square root of 9, that would be 4 times the square root, 4 times 3, which is the square root of 9, times radical 2. So this then is 20 radical 2 minus, don't forget what operation you're doing, 12 radical 2. So all I have to do is subtract my coefficients and I get 8 radical 2. And that is your simplified version. Again, you may want to pause the video now and go back to your notes sheet and do the couple of examples where you practice simplifying to combine like radicals. All right, back to it. You're going to see here, a progression of a lot of the skills that you've learned so far. This first example looks a lot like distributive property because you need to take that square root of 10 and multiply it by everything on the inside. So when you take the square root of 10 times the square root of 6, that's the same thing as the square root of 60, and then you take, so you multiply those, and then you need to take the square root of 10 times 3, which is 3 times the square root of 10. From there, again, you want to look to see if there are any perfect squares within there. So you could write the square root of 60 times the square root of 4 times the square root of 15, which the square root of 4 is 2. So you have 2 times the square root of 15. And then you still have your 3 times the square root of 10, because there's nothing you can really break 10 down to simplify that radical. So your final answer is 2 times the square root of 15 plus 3 times the square root of 10. Our second example, you are taking the square root of 11 minus 2 and the whole thing squared. I'm going to show you the long version, and then I'm going to try to remind you about that shortcut, about the difference of two squares. So if you wrote this out, I'm going to grab a different color. If you wrote this out, it means the square root of 11 minus 2 multiplied by itself. So times the square root of 11 minus 2. Well, this looks a lot like when you needed to FOIL. So when I multiplied my first, when you take the square root of 11 times the square root of 11, you should get 11. And then you multiply your outers, so that would be minus 2 times the square root of 11. Then you multiply your inners, and you get 2 times the square root of 11. And then you multiply your last, negative 2 times negative 2 would be 4. Then you want to make sure and combine like terms, so this would be 11 minus 4 times the square root of 11 plus 4. And then if you look, you have 11 plus 4, so that would be 15 minus 4 times the square root of 11. Now, if you remember that shortcut when you square your first term? So the square root of 11 squared would be 11, which is what we got there and there. Then you multiply these two and double it, so that would be negative 2 times the square root of 11. Double it would be negative 4, which is what you have right there. And then you take this term and square it, and negative 2 squared is positive 4, which is what you got there. So don't think that those rules have gone away. They will provide shortcuts and make this a little bit easier if you can remember those. All right, take some time, flip back to your note sheet. It's the next one called multiplying radicals, and work through some of the examples. All right, let's learn how to rationalize a denominator using a conjugate. Big words, fancy words, and I think this is going to be one of those moments where you say, wow, this could be really, really ugly, but if you remember some of the tricks that you've learned along the way, this really isn't so bad. So, as you know, we don't really like square roots in the bottom of a fraction on the denominator because it looks ugly. So we want to get rid of them. And we are subtracting 2 square roots. And to undo a square root is to square it. So we need to figure out how to get rid of these. And the easiest way is to multiply by the conjugate. And mathematically, I think it will start to make sense. So the conjugate of this would be the square root of 7 plus the square root of 2. And you know that as long as you multiply the top and bottom of a fraction by the exact same thing, it's 1. And you can multiply anything by 1. That's your identity property there. You can multiply anything by 1 and it stays the same. So as long as you multiply both of these by the square root of 7 plus the square root of 2, you're multiplying by 1, which again is your identity property, so it's staying the same. Now, back to last unit, when we worked through these, when you subtracted something and added something, remember that it canceled out when you FOILed. So I'm going to show you, I'm going to remind you what happens when you do this, and then I think you'll understand why we're going to do this. So the square root of 7 minus the square root of 2 multiplied times the quantity, the square root of 7 plus the square root of 2. If you go through and multiply these, when you multiply your first, the square root of 7 times the square root of 7 is 7. Then when you do your outers, it would be the square root of 7 times the square root of 2. Then you do your inners, which is minus the square root of 7 times the square root of 2. And then you multiply your outers, which is negative square root of 2 times the positive square root of 2, which would just be minus 2. Well, if you look at this, you're adding and subtracting the exact same term, which cancels them, which is a beautiful thing in this case, because then you're left with 7 minus 2, which is 5. So since I've worked this out, I'm gonna cheat over here, and I'm gonna put 5 because I've shown you how we worked that out. And then on the top, you have, 10 times the square root of 7 plus the square root of 2. Well, look at this. You have a 10 on the top of your fraction, a 5 on the bottom. Those cancel pretty nicely. So you're left with 2 on the top, 1 on the bottom. 1 as a denominator is not necessary. So your most simplified version, I'm going to write it in a different color here, is 2 times the square root of 7 plus the square root of 2. Then, if, depending on what they want your answer written as, you may have to distribute this. So you would multiply your 2 times your radical 7, and then 2 times your radical 2. And there is your simplified version of this original problem over here that had square roots in the denominator. All right, one more, because you might be scratching your head a little bit. Here is my original problem, which is negative 3 over the square root of 10 plus the square root of 5. Again, we don't want those square roots in our denominator. So in this case, we need to multiply by the conjugate. And the conjugate would be, if you want to think about it, you want to get rid of these square roots. So you want to just simply multiply by taking those 2 and subtracting them. So I'm going to multiply by the square root of 10 minus the square root of 5 on both sides. All right, I'm gonna use a shortcut. So what you're doing is you're gonna take the square root of 10 times the square root of 10, which is 10, and then you would take a positive square root of 5 times the square root of 10, and then a negative square root of 5 times 10, which essentially cancel each other out. So I know that they're gone because it's going to be 0. But then I have my positive square root of 5 times my negative square root of 5, which would be negative 5. Because the square root of 5 times the square root of 5, you've got a negative in there, it's got to be negative 5. Up on the top, I have negative 3 times the square root of 10 minus, sorry, that pretty big, minus the square root of 5. So on the bottom, actually on the top, I'm going to rewrite this. I have negative 3 times the square root of 10 minus the square root of 5, and on the bottom, I've got 5. My 3 doesn't simplify with my 5 very easily, so I am just going to distribute my numerator. So that would be negative, sorry about that. I'm going to do negative 3 times the square root of 10 plus, because I've got a negative 3, I've got a negative 3 and a negative 5, so plus 3 times the square root of 5 all over 5. And there is that solution. All right, that's it. Go give it a shot yourself. You know that I'm always here to answer questions. And as always, the first day, you guys might be a little confused, but at the end, you are good to go. All right, good luck.